All right, class, welcome to Unit 5. You're almost to the halfway point. In this week's discussion, you're going to have an extra little challenge to get through the complete discussion, and that will be that you have to learn how to conduct t-tests for means as part of your task to get through the escape room and figure out the secret code. And a big part of that figuring out the secret code is going to involve being able to conduct the different types of t-tests for means using Excel. So first thing is, let's realize that from this unit, you'll be learning about 3 different types of t-tests. All of the t-tests that you'll be learning this week are ways to compare means. So you'll be comparing quantitative variables. But a lot depends on how many samples are involved in the test that you're conducting. So I've got 3 examples here that are going to be similar to the ones that you see in the discussion. And I first want to talk about how are we going to know which type of t-test to run. The first example says, do students in section A perform significantly better than the previous mean of 80? So what I want you to notice here is that there is already a numerical value provided that we are comparing to, and we're only comparing one sample of students. In other words, we're only comparing students from section A. So a random sample of students from section A would be taken, their sample mean would be calculated, and the one sample t-test would need to be used to compare the sample mean to a numerical value of 80 to see if the evidence is strong enough to indicate that students in section A perform better or not. Example 2, is there a significant difference in the performance of section A and section B? So now, because we are comparing 2 sections of students, that implies that we would have to take a sample of students from section A and then a sample of students from section B. And because those 2 samples consist of totally different students that are not related, then we would need to use an independent samples t-test there, because we're comparing 2 groups that are independent of each other. They're not related. And our third example, did students show significant improvement throughout the term? And when I bring up the data sets in just a second, you'll see that there are pre-test scores and post-test scores that we would need to compare to be able to see if the evidence indicates that the students showed significant improvement throughout the term. But what we need to realize with example 3 is that the sample of students that we get the pre-test scores on would need to be the exact same students that we get the sample of the post-test scores from. It wouldn't really make sense or be anything valid if we compared pre-test scores from totally different people than post-test scores. So we have to use the same students in both of those samples, and therefore those 2 samples are dependent samples. Basically, they are the same people in both groups, and therefore we'll be using what's called a paired samples t-test. Another thing to notice, as we discussed last week when we were first really being introduced to hypothesis testing, we have to pay attention to the wording to also determine whether we're going to be doing a one-tailed test with a less than or a greater than symbol in the alternative hypothesis, or whether we're going to do a 2-tailed test where we're not testing a specific direction, but rather just testing whether there's evidence of a significant difference or not. So in example 1, you would want to notice the keyword better right here, because if we are testing to see if evidence indicates if students in section A perform significantly better than the mean of 80, then that hints at the fact that we will be doing a one-tailed test and specifically using the greater than symbol. Because in terms of grades, better means higher than. Example 2, you would want to notice the words, is there a significant difference? Because the words significant difference do not imply a specific direction. That could mean either higher or lower. Section A could perform either higher or lower than section B, and either one of those could be considered a significant difference. So those words indicate a 2-tailed test. And example 3, you would want to notice the keyword improvement, because if students take a pre-test and then take a post-test, and if it involves grades, then the word improvement would imply that the post-test scores minus the pre-test scores would need to be something positive, because rather than negative, because If there's been improvement when the students take the post-test, it means the post-test would be higher. We would have evidence that the post-test scores are higher than the pre-test. And in that particular type of test, we look at differences. So if we choose the order post-test minus pre-test, that would imply improvement would imply that we would have a higher number minus a lower number, so we'd get a positive difference. So these will be things we think about when I show you how to run these 3 different types of t-test in Excel and be able to come up and calculate your test statistic and your p-value so that you can make your conclusion. All right, so let's go ahead and open up the spreadsheet that I've prepared for the video. It will be similar to the spreadsheet that you will use to help you get through the escape room task in your Unit 5 discussion. So you see that column A are section A scores, column B section B scores, column C pre-test scores, and column D post-test scores. So the first thing I'm going to show you is how do we answer example 1, which was asking the question, do students in section A perform significantly better than the previous mean of an 80? Now, Excel is not perfectly equipped for doing a one sample t-test. There's other technology that honestly runs it a little bit more smoothly, but we're using Excel in here for many different reasons. And so I'll walk you through how you can still get Excel to conduct a one sample t-test. It just means you have to create a new column, and I'll show you some different things there. So since the number that we are testing in example 1 and for the one sample t-test is the number 80. Remember, the question was, do students in section A perform better than the previous mean of 80? Then I'm going to need to come over here to column E. I'm just going to put a title of scores. And since the number I'm testing is an 80, then I'm going to type the number 80 in the top cell of column E. And to make it quicker, we're wanting to really put the number 80 straight down this column because it's that single numerical value that we're comparing against. So I'm going to click my mouse in the first cell here, really cell E2. I'm going to come over here to the right-hand lower corner until you see that black cross. And I'm going to click and drag down all of column E until I get to the end here and make it even with the other columns and stop it off here at cell 41, E41. And you'll see that when I lift up my mouse, it went ahead and copied those really quickly rather than having to type a bunch of 80s down there. You don't really want to do that. That's too time consuming. All right, so now to do the one sample t-test. We'll need to use the data analysis Toolpak to conduct all 3 of our types of t-tests this week. So hopefully back in Unit 1, you got that installed. Otherwise, you would have to refer back to the Unit 1 video on installing the data analysis Toolpak. And in this particular example, I'm only going to be using the section A scores here in column A and column E scores, which are all the number 80, because technically I'm just doing a one sample test and comparing to the numerical value of 80. So I'm going to come up here to data. And notice I've got my data analysis Toolpak installed. Otherwise, data analysis would not show up over here. So I'm going to click on that, and it will bring up this pop-up. Now, when you scroll and look through things, you see the t-tests are all bunched together here. But we see that Excel only has a paired 2 sample, a 2 sample assuming equal variances, and a 2 sample assuming unequal variances. There are no other types of t-tests that Excel does, which is what I meant when I said Excel is not readily equipped to do a one sample t, but we can get it to do that. Okay, so what we're going to want to do is go ahead and highlight t-test 2 sample assuming unequal variances. For anything involving 2 samples, your book always assumes, your text always assumes, tells us to assume unequal variances. And even though technically this is a one sample test, we're going to click on the 2 sample, but make sure we assume unequal variances. And then I'll click OK, and I should get this pop-up. And typically, you're going to probably not have anything in these boxes right here. So let me delete this just because, like I said, I don't think you're going to really have anything here when you first open it up. Okay, Variable 1 range. Well, remember the main group that we're really looking at here is section A, the scores of the students in section A. And that's really technically where our one sample is coming from. So for variable 1 range, I'm going to click on column A, and I can really just click this heading here and it will highlight all the values. So I'm going to click on that, and actually put it down here, but it shouldn't have. Let me take that off. Yeah, actually, let me go back and pull it up. Okay, yep. So click my mouse in the variable 1 range box. Come here and click on column A. I always double check just to make sure it's putting things where I want it to, which was how I caught that mistake. So notice it's putting column A in the variable 1 box. In the variable 2 box, remember we're comparing the scores of the section A sample of students to the numerical value of 80. So I want my variable 2 to come from column E. So click my mouse in the variable 2 box to where the cursor is flashing in that box. And I'm going to come over here and click my mouse on top of where it says column E. And just do a quick left click there. And I check and make sure that it's got column E in the variable 2 range. Since I did include labels, because each of those 2 columns had label headings, then I want to make sure I check the labels box. And I do want my hypothesized mean difference to be 0. It may be that by default, it probably will be, but just otherwise make sure that the hypothesized mean difference box says 0 right here. Alpha is by default going to say 0.05. Just double check and make sure it does. And then depending on where you want to put your output, if you want it to end up in a brand new Excel spreadsheet, you can click New Workbook down here. If you want it to just be on a new sheet, you can leave this radio button checked. Or if you want it to show up in the actual same sheet that we're in right now, then we can click in the output range box, and wherever we want the output to be pasted. So I'm going to come click my mouse in there, and I think I'll just click, say, right here around I-10, and that's where the output will go. So I'm going to click my mouse here. Notice it put I-10 in that output range, which is where you'll see the Excel output ends up. And then I'm ready to go ahead and click OK. And here's our output. I'm going to stretch these columns out a little bit so we can see it better. All right, and the main thing is that I'm actually going to change this to say, instead of to say t-test 2 sample assuming equal variances, I'm actually going to change this, delete it, highlight and delete, and say really t-test 1 sample t-test, because that's what it is. Meaning we will really ignore this second column right here, and we're going to be focused on the output in this column right here. The sample mean of the section A scores is 82.175. Now, just because that number is higher than 80 doesn't mean it's significantly higher. That difference may be so small that we attribute it just to random variation, random chance. So, hypothesis testing is really all about, are we seeing significant or strong enough differences that it's probably unlikely just to be random variation, and probably that there really is a true difference? Well, we have yet to see that, because we've got to go down, look at our test statistic and our p-value before we can answer that question. So we had 40 observations. Degrees of freedom is n-1, so that's 40 minus 1, which is 39. And here is our test statistic. It means that the 82.175 is actually 3.429 roughly standard deviation units higher than an 80 once you bring in standard deviation. And they gave us variance. They don't give us standard deviation in this output, but standard deviation is the square root of that variance number. And here is what is most important, the p-values. And the p-values, you're either going to want to look at this that says probability t less than or equal to t for a one-tailed. That would be the one-tailed p-value. This would be the two-tailed p-value. The one that you look at depends on whether your test was one-tailed or two-tailed. Now, keep in mind, our test was one-tailed because we were looking whether the evidence indicated that this section A student scored significantly better, greater than a score of 80. And so, therefore, we are going to use this one-tailed p-value, which is 0.00072 roughly. Certainly when we compare that to 0.05, then it is a low p-value. So in this case, our decision would be to reject the null because our p-value is low, reject HO, and conclude that we do have significant evidence to say that the section A scores are higher than the previous mean of 80. In your escape room spreadsheet that you'll be working through to try to escape, it will ask you questions like, what's your test statistic? Well, that's the t-stat number. What's your p-value? That would be this in this case. But, definitely pay attention in your escape room task as to whether you're doing one-tailed or two-tailed. They're not going to necessarily be identical to these exact questions or these questions that you're seeing in my video. So make sure you think about all those keywords. All right. So that's how easy it is to do a one sample t-test using Excel, even though Excel doesn't really, isn't really set up to do it. It's not really that hard once you know to add in this extra column that consists of whatever that numerical value is that you're testing. All right, let me delete through this now. All right, I don't know why it didn't take out the highlights, but that's okay. We'll just paste over it. All right, next thing is, let's see, example 2 was, do students in section A perform significant, or is there a significant difference in the performance of students in section A and students in section B? And we had said that that was going to end up being an independent samples t-test because we were comparing two groups where the two groups were totally different students. All right, so we, in order to conduct an independent samples t-test using Excel, you would still come up here and click on data, come over here to data analysis, and go back to what we were still using before, t-test, to sample, and still always assuming unequal variances. There are other things that you could get to in another level of statistics where you learn how to do even another test to decide whether you have equal or unequal variances. There's not that much of a difference, honestly, between those two tests. But for our course and what our text assumes is unequal variances. So you'll make sure that you always click on that when you're doing an independent samples t-test. So we'll click OK. We'll get the same pop-up. But I am now going to take out variable 2 range with the column E, and I'm now going to take my mouse and left click on top of the B, so that now I'm comparing column A and column B, which are the section A students and the section B students. We're still going to keep our hypothesized mean difference of 0, because if you recall, remember the null hypothesis, HO, always assumes that there's no difference. So, we go into a test assuming that the difference is 0 unless we get strong enough evidence to reject the null. We do have labels in our column, so we leave that checked, and we keep the alpha at 0.05. Output range, I'm just going to leave it I-10. That seemed a pretty middle-of-the-road place to have our output pasted. And then I'll click OK. And notice now it is giving us different results. And I'm going to leave it where it says to sample, assuming unequal variances. Stretch this out a little bit more. Stretch this out a little bit more. And notice now we are going to be looking at both of these means. Before in the earlier example for the one sample, I said ignore this, but because they were all the number 80. But now we pay attention to it. The mean of the section A students on their test was 82.175. We already knew that from before. Section B's mean is 85.225. So it's a difference, but we don't know if it's a significant difference in their scores until we look at our test statistic and p-value. Again, that difference may be, attributed to just random variation, chance variation, if it's not really considered a strong enough difference. But if it's a strong enough difference in terms of standard deviation units, then that would indicate, we would get a low p-value, and that would indicate that this difference is probably not just chance variation because it's too strong of a difference. So we'll have to look to our p-value to tell that. So now here is our new test statistic, roughly around a negative 2.806. The reason it's negative is because whichever one you clicked on first, which was section A scores, it's going to make the difference be section A minus section B. And since the sample mean of section A was lower, then when you subtracted, it gave a negative difference. Okay. Now, it's not just strictly the difference. We also, in order to get the t-test statistic, had to incorporate standard deviation. But because the section A mean was smaller, it still resulted in a negative test statistic. For our p-value now, because in example 2, we were just testing whether there was a significant difference between the two sections, then we are now going to look at the two-tailed p-value. And so our p-value that we would use for the conclusions would now be the 0.006 that we would look at. That is also definitely lower than 0.05. And so therefore, once again, we would reject the null and conclude that we have significant evidence to say that there is a significant difference between the section A student scores and the section B student scores. And specifically, since section B score, their sample mean was higher, then we can say specifically that significant difference is that section B appears to score higher than section A. Or in reverse, you can say specifically the evidence indicates that section A performs worse than section B or lower than section B. Just depends on the order that you make your statement. All right, so that is how to get the output and the test statistic and the p-value for the independent samples t-test. And again, you have to be careful as to whether you're going to actually use the one-tailed p-value or the two-tailed p-value based on the wording of the question that you get in the Unit 5 discussion. And finally, our last test will be the paired samples t-test, and that's when you have dependent samples, two samples that are dependent. And that was when we were going to compare the pre-test and the post-test scores to see if the evidence indicated that the students had shown significant improvement, after taking the course or something like that. We can imagine that many professors, many teachers use pre-test and post-test scores to provide evidence as to whether their students improved over the term or not, or if it's students in high school or something like that, to see whether their students improved over the school year. So now we are going to do the paired samples t-test. So back to data analysis, but now we come up here to where it says t-test paired to sample for means. Paired samples t-test. So I'll click OK. And we get a very similar looking pop-up window, but now our variable 1 range. And, it totally depends on which order you want to do it in. I'm going to actually go ahead and do post-test minus pre-test, just because it's easier for me to think of that being a positive difference if the post-test scores are higher. But you can do it whatever order you want, as long as you're careful about whether you're looking for, positive or negative differences. So I'm going to let variable 1 be the post-test scores. Left click on top of column D, make sure it put D in there. Then I'm going to go in variable 2 and left click on the top of column C, which are my pre-test scores. Check and make sure it put column C in there. Once again, hypothesize mean difference of 0. I did have labels included in the tops of those columns, keeping alpha 0.05. And I'm going to go ahead and still click output range and click in I10 again, was where I had it. Let's see, click my mouse right there. While the cursor's flashing, I'm going to go ahead and click in I10. All right, then click OK. All right, there it is. Not sure why that took a little bit delay time, but there it is. Notice it says paired to sample for means. That's the right test we wanted to conduct. And we get information on both post-test and pre-test. Post-test, the mean score on the post-test for that group was 85.975. Pre-test mean was a 51.325. There certainly does appear to be a significant difference, but we don't know for sure until we check the test statistic and the p-value. Notice the degrees of freedom for the paired t-test is still the same as it was for the one sample. In fact, the paired samples t-test is very much the same as a one sample t-test, but it's just run on differences between the post-test and pre-test scores. So it's got the same degrees of freedom of 40 minus 1. Our test statistic, a very large test statistic, meaning it's way out there on the t-distribution. And as we've talked about in class, and even last week when we were first learning about hypothesis testing, the farther out your test statistic is out in the tails, the stronger and stronger evidence you're getting to reject. And since I was specifically looking for whether there was indication of a significant improvement, then I was also going to do a one-tailed test, and therefore I'm looking at the one-tailed p-value. Well, you need to look at the complete number. P-value cannot be a 2.93. It's got to be a probability between 0 and 1. So you really need to look at the end here and notice when you see E, negative 27. That is scientific notation, meaning that this number is really the number that you would get if you took that decimal point between the 2 and the 9 and moved it 27 places to the left. Well, you would have 0.00000 on and on and on, and an extremely small p-value, basically giving you very strong evidence that yes, there is evidence that the post-test score showed significant improvement in the students over the term. So in these examples, we didn't see any high p-values that were greater than 0.05. If we had, we would have failed to reject the null and said that we did not have evidence to conclude significant differences or significant improvements. But in these 3 examples, we did get significant results for all of them. So in all cases, we would reject the null and conclude that yes, we do have significant evidence. So you'll be working on the wording in here in the discussion. You'll be working on the calculations using Excel, and all of this will help you be able to hopefully complete all the tasks that you need to and be able to escape the tea room, get that secret code, and be able to fully complete your Unit 5 discussion. So have fun this week. Hopefully this helped walk you through each of the types of t-tests so that doing the calculations for the different t-tests will be a piece of cake, and you just got to work now on interpreting all those results. So good luck getting out of that escape room.